So this is chapter one, our kind of traditional introduction to the subject. Basically, what is statistics? And so I'm going to use the slides just to kind of preface it. I'm going to use the slides that are provided by the publisher. I'm not going to necessarily be reading the slides because I'm going to assume you can do that, but I'm going to really use it. Sorry, I'm going to use it as a motivation for talking about what's going on in a chapter. Okay. And what I did just to help myself is you'll hear an occasional rumbling of papers, but that's just because I printed it out beforehand to kind of plan out what I was going to say. So these are the learning objectives for this chapter. It's useful if only because it gives us an overview of what's going to go on here. So we're just going to do some very basic definitions in statistics, get us all on the same page here. And then really the most meaningful thing we'll do here is we'll talk about two ways that data tends to be presented. So let's just start with kind of a series of definitions here. The first would be the population. So as the slide does say here, it would be a specific collection of objects of interest. Essentially, what a population does for us is it identifies, it's probably the largest grouping that we can have here. So an example of a population would be automobiles in the United States. So from the textbook, this kind of example is given. So if we looked at all the automobiles in the United States, that would be the population. Then what we take from that population of automobiles, we would have some sort of number that we're going to attach to things. Now that's the measurement. So the measurement is just the number itself. It could be, in this case of the population, it could be the millions of cars, or most of the time it's pretty costly, it's pretty difficult to take into account the entire population. So instead what we typically do is we take a sample. Now that sample can typically be sort of a subset of the population. So an example of that would be something like we could look at new automobiles versus used automobiles. We could look at cars made in the United States and used in the United States versus cars made overseas but used in the United States. Cars made in the last 10 years, cars made in the last 5 years. Any sort of way that we could, cars that are red, a number of ways that we could take into account a subset of the total population. Now, connected to this, usually what we're doing is we're using the sample to be able to talk about the entire population in a meaningful way. So typically what we are trying to do, instead of presenting to you the entire population of, let's say, 30 million vehicles out there, no, let's not be theoretical about this here. So why don't we just do something like this? $276 million vehicles registered in the U.S. Now, of that, we can see we have some samples here: cars, motorcycles, buses. We can see other ways of doing it. We could do it by state. So it gives us some kind of ideas of understanding that statistic of a population of 276 million. But what we would typically want to do is we'd want to talk about a parameter. Meaning we don't typically want to talk about, how many 276 million vehicles. Typically, we want a number, a measurement that summarizes some aspect of it. So, as an example, we could look at something like how much are they all worth? I'm not sure if we can find that kind of information here. But we could imagine there's some way, there's some possible way to talk about, in terms of a parameter, the dollar value. So what we, again, could do, instead of looking at the population as a whole of all the vehicles, what we could do is take a sample. So let's just say we take 500 cars from that population. That's going to be our sample. Then what we could do is find the monetary value of those 500 cars, and we could create from that data, a measurement that would be able to talk about a parameter, a summary in some sense of the population as a whole. Either like the average value of the 500 vehicles in our sample, something along those lines. The final definition here from this slide is census. And in some sense, it just means that a census would just be a sample where the sample represents the entire population. I've got a good one here. The census, we have a census here that's taken every day here at the university. And if I scroll down over here, so we would say it's a sample, but the sample is the entire population of students at UH. So in this case, at West Oahu, we have a census of 2,824 students for 2022 spring semester. Okay. So this course is obviously a statistics course. So what does it mean when we're talking about a statistics course? We're really just talking about methods. We're talking about methods for how you collect the data in the first place. How do we display it to the reader? And more importantly for me, how do you analyze it and draw conclusions? Because if you can't analyze it and draw conclusions from it, what's the whole point of collecting it and displaying it? Displaying it would mean like showing a bar graph, stuff like that. Collecting would mean, what kind of techniques are you going to use to find the data? So from that general discipline of statistics, we take from that descriptive statistics and inferential statistics. So these are kind of the two branches of study. When we talk about descriptive statistics, we're talking about how data is organized, displayed, and described. What does that mean? It means that with descriptive statistics, we're talking about how the data itself is organized, for instance, within an Excel spreadsheet. And then we would talk about different ways to both display that data and describe that data. Describing the data would be something like taking an average, taking a median, looking at the distribution. Displaying it would mean, how do we graphically show what's going on and showing the relationships even perhaps between variables. Descriptive statistics is useful for kind of getting a good understanding of what's going on in the data on kind of a bird's eye view. What's probably more the reason, though, why most of you are required to take this course isn't your ability to do descriptive statistics, in my opinion, but rather your ability to do inferential statistics. Your ability to take data and draw conclusions about the entire population based on a sample of the data. Think about what discipline is your primary field of study. Whether it be business or the social sciences, you typically don't have access to the entire population. Rather, you have only a sample, either randomly drawn or drawn in some meaningful way. And since the sample is what you can meaningfully collect data about, then what you need to do is use inferential statistics to describe what's going on in the sample and then extend those conclusions to the population as a whole. So that would mean also then things like, how strong is your sample? Are there any biases in how that sample was drawn? That sort of thing. Okay. Now, when we talk about data, the data itself does not need to be numerical. So, for instance, if we go back to our automobile example, what we could say is we would also perhaps have data about automobile, about like what's the color, who made the car, is it a sedan, is it a pickup truck, that kind of thing. So those would be categorical variables or qualitative data, as opposed to the quantitative data where we have a natural numerical scale, something like how old is the car, right? Because then you would have a year. How much was the car's purchase price, where again you would have a very specific number. Within statistics, we want to use both qualitative data and quantitative data and merge those two forms of data to talk about things meaningfully. And then again, in inferential statistics, take the qualitative data and the quantitative data we have for our sample and be able to draw conclusions about the population as a whole. So when we take all this into account, sorry, I just have to get to that slide here. So when we would take all this into account, we get kind of an overview of what's going on then in all the chapters. And we're going to get through, at least through chapter 10 here in this course. And what we're seeing here as we talk about each of these chapters, what we're able to do is take statistics, which is again a general study of data, and we're going to use both descriptive statistics and inferential statistics. With descriptive statistics, like in chapter 2, we will talk about how data can be described. And then we will use inferential statistics, where we make conclusions about the population based on the information in the sample. So you can kind of see things along with that in things like chapter 9, for instance, where you have two sample inferences being drawn. Okay. In general, as we work through these chapters, my goal is not to make you a statistician, which I don't think most of you are intending to be. Rather, you want to know, why is this class required for your course of study, and how is it going to help me understand, help me get a job, help me understand better what's going on in my discipline. So that's kind of my motivation in how I'm organizing things. Okay, so let's get through. I don't want to repeat what's going on here. Okay. So let's start first here, talking about how data is presented. We generally would use two ways of presenting data. In the first, we could talk about having a data list. So basically all that is just listing out each of the individual measurements, either putting a space between each of the numbers or having some common way of distinguishing one number from another. So using something like a comma, a colon, quote marks, some way to separate out each of the individual data points. And so you can present it again in a way where with the data list, having it presented here with spaces in between, or in set notation, where you distinguish it with commas in between each of the individual measurements. Commas, again, you could imagine semicolons being used, but something consistently being used between them. Now, what we can also use besides a data list and a set notation would be a frequency table. I'm sorry, let me pause this here very briefly. Okay, so continuing on here. What we see down here would be our frequency distribution, which would be somewhat useful because you can see numbers like 18 are repeated a few times, 19 is repeated a few times. So another way of describing the data would be to talk about the frequency in which certain measurements were captured. And so, depending again on what we're looking at, that would be useful. Now, how would that apply? Like, how would that be useful for you? Well, let's say you're selling something, and it's something that it has individual components to it. You'd want to know like how to package the item. So, for instance, I don't know what the logic is behind hot dog buns being sold in packages of 6, but for some reason someone has discovered, or 8, or what, I think it's 8, right? But the buns are 6, something like that. Well, one way you could approach it statistically would be that you you take a sample of consumers and find out how many they're typically purchasing, right? If you could find a way that you asked customers, how many individual hot dogs would you buy? How many individual hot dog buns would you buy? And then you would look at that frequency distribution as you would down here, and you'd be able to identify what the preference is for how many individuals would buy. Here, this would be a package of 18 of something. And that would be a pretty informed way of determining your product size. Okay. We've already done this, so but what I guess I like about this slide though as well is it gives us a perhaps simpler way of talking about each of these key terms, where again the population would be all the objects, so in this case all automobiles. Then the sample would be a subset or sub-collection of the population. So we could talk about like automobiles in the United States. The measurement again would be the number that we use. So the number of automobiles, we could say in the United States is 276 million. That 276 would be our measurement. Then our sample data is, we're not going to look at all 276 million vehicles, but rather we would try to take a sample either based on time, state, some sort of limiting characteristic. Based on that sample data, as we start to describe it, we would be able to draw from it certain parameters that can describe the entire population. And then finally, we can calculate from those, from that sample data, we can calculate various statistics that describe the overall data and hopefully allow us to make conclusions about the population. Okay. And again, we've looked at this, so I'm not going to repeat this again. And we've talked about this. And I've even really talked about this, which again, we'll basically do two things in this class. We'll do both descriptive statistics and inferential statistics, with the goal being that we typically can't know everything about the population. Rather, we're going to take samples and we're going to make inferences educated guesses, basically, which is why it's called inferential statistics. We're going to make educated guesses about the population based on the sample that we've drawn upon. And that's essentially it. The quality of what we do here is going to be trying to make then conclusions on the data based on the inferences that we're drawing and the quality of the samples that we've taken it from. And that's it. Okay, so this is a rather short chapter, if only because it is an introduction. And it should have hopefully been a pretty easy read within the textbook, because again, all we were just trying to do is introduce the general idea of what qualitative data is, quantitative data, a sample versus a population, and then descriptive versus inferential statistics. Okay, if you have any questions, let me know.